and I hope all of you have getting clear the contents with these online classes. Since nobody is asking any doubts, that I feel you are comfortable with the method we are discussing over here. So here the trust members are considered for the section. Okay, I think the screen is visible for you now. Okay, so here the trusses are considered and the types, and that is when there is a ground level, on the slab where the vehicles are getting the truss member at the top, then that members are that is the type of truss. And again we have another type of truss which is having like this in this manner. That is that is the type of truss. And again, when these two types of trusses are considered for the evaluation or analysis for the different types of stresses within it, and that may be considered with reference to the type of the truss. So that means, so the type first one, whatever here it is drawn, say this one, that is the type of truss, that is throw type, that you can write here, throw type of truss. So that means when the load, when the particular load is moving on the on this part, when the particular load is moving on this part, and this part this member will be under tension, this member will be under tension, and these members will be under compressions at the certain points. And at the here if you consider this truss is considered to be a deck type truss. So this is the deck type truss and this is the throw type truss. So in this deck type of truss, when the load is moving on this part, the upper parts of the truss members will be under tension. But in the throw types of truss, the lower part of the members will be in tension. That is simple over here. If the member is considered like this, when the load is applied on the certain point, this will be under bending, and since it is bending, that means there will be a tension force, right? The tension force will be, that means the particles are the elements in the member are trying to move away from the point, like this. So that is the same case. Here, if the load is moving on this point, then the particular deformation can be observed in this manner. And for this member, for the throw type truss, the load will be moving on the bottom members, and that point the deformation or deflection that may be considered in this manner. That is the case, we are going to consider the types of members over here. And again, here the particular members that shall be observed based on the conditions that is given. And here see, that is, and this is an example I have taken for the discussion here today. So here we have any members and the different, having diagonal members, vertical members, and horizontal members also. So in these members, they may be asked to calculate the forces in the members in the given trusses. So since it is having a symmetry, here we have symmetry to U3 and L3. I hope you are U3 and L3 will be having the symmetric section. So here, if you see, this is a section. So on this part, that is will be considered for the analysis, and the same thing will be referred for the other section. So now here it is asked to calculate the kinds of members for the analysis. And this problem is considered only to illustrate how exactly the analysis are carried out. Here we are not any considering any values, any number, any load values or any span values like that, any angle values. Just we are illustrating how exactly we are going to consider as for the solutions. Since here I will start with the top chord members. So what are the top chord members over here? And this is a top chord member, right? And this is a top chord members. And the green that is I will write with the that is top chord members. And at the same time, if the L0, L1, and L1, L2, and L2, L3 will be the bottom chord members, right? Will be the bottom chord members. So now, and apart from this, we have another type, another load, which is diagonal load, diagonal members. So these are the diagonal members that can be considered. Apart from that, we have another member which is vertical, right? So we have these many members in the truss on in a symmetry. So it is the question to calculate for the top chord members, and that means the forces in the half of the section. But exactly when the question is asked in your final examination, there they will ask only for the members. They will give the notations over there in which member you are going to calculate for the particular values. So that means if they give the points over here, then at that point you need to consider or you need to find out the forces in the diagonal members. And here they may give any notations like this. You may have to calculate the forces in the U4, U5 members. And here may they give another notation. That means you may have to calculate or analyze for U5 and L5 members. That means they will ask the particular members to calculate the forces. But in this case, what I am trying to explain is I will directly consider all the forces. I will discuss all the members over here. Then later we can consider any one of the member for the analysis of for given values in the trusses. So if you observe here L0, L1, L0, L1 is a member that is having uh, inclination with an angle of theta. This is the angle of inclination with a theta. So for this, if you want to calculate the force in the member, so how do you calculate? Just it is the similar type what we have gone through the analysis of trusses, with the method of section and with the method of joint, like that. So just we need to resolve the forces to the vertical, to the horizontal. Later we will be analyzing the parts. That is the same thing what we had discussed in the truss analysis of trusses in the first module. So now here P L0 L1. So P is refers to force, or F we can say, or P we can say, any one of the notation we can refer. P L0 L1 having the inclination with an theta. So if you resolve that force to the vertical, then the P L0 L1 can be written as P L0 L0 U1 with P L0 U1. This is U1 and L0 U1 with sin theta, because this is 90 minus theta. right? So since it is 90 minus theta, then that can be written as P L naught U1 sin theta, and apart which is moving away from the joint. And apart from this, we have another reaction over here for the same point, and we can consider the R1. So if you resolve this, PL naught U1, which is equal to minus R1 sin theta, that is dividing with the sin theta. Since it is a negative sign will be considered for the compression, and positive sign will be considered for tension. So that means L0 U1 is the member in compression force. L0 U1 is the member which is in compression force, having the value of R1 by sin theta. So reaction force that can be calculated by referring to the load values and the span distances, and sin theta will be having the angle, right? So that means PL0 U1 PL0 U1 having the compression force with the R1 by sin theta value, right? So I hope it is clear how we have calculated this. Just we have resolved the force of PL0 U1 to the vertical, and that will be PL0 U1 sin theta. Along with that, we have another reaction at that same point for the member, that is R1. Since if you resolve this force PL0 U1, which is equal to minus R1 by sin theta. So this minus this sign can be considered for the compression members. So now when you consider this one, but the load is moving. Since the load is moving, or the load may be considered any one point, say like that the load is at L0, that means the load is acting at this L0, or the load is acting at L1, like that. The any of the point the load is maybe acting, or any in the span between L0 and L1, the load may be acting in between these two. So like that, if the load may be expected in any of the place or any of the position in the span, so that means what would be the equation? So this equation will be altered with considered location of load. So here when the unit load is at L1, so if it is considered the unit load at the position L1 over here, if you consider the unit load position at L1, so what would be the value here? So once the load is at L1, the reaction forces need to be known. So how do you consider reaction force? So here it is a section, and that means the whatever the load is acting at this position, the R1 that can be written, considering the other part of the section over here, on either on the opposite part of the section of R1. So what is the opposite part of the section here? Uh, this is the length. Total opposite part of the section is this is the length. For overall length, how much it is? 6 numbers. So 1, 2, 3, 4, 5, and 6. 6 numbers are there. And in opposite part, how many spans are there? 5 spans. So that means R1 that can be written as 5 by 6. That means the unit load, it is considered to be an unit load which is acting at the L1. So since it is acting at L1, then reaction at R1 that can be considered the 5/6 of the load. 5/6 of the load. And at the same time, if you consider for R2, it is considered for R2 that will be 1 by 6, because on the opposite side of this section for the R2 will be having only one part. So that is, for the total 6 parts, we have only one part on the other side, that is 1 by 6. So at the same time, when the load is at L1, the L1 the whatever the equations we have considered, we have derived here, the R1 value is substituted. Since the R1 is 5 by 6 when the load is at L1, then it will be 5 by 6 into 1 by sin theta. Is 1 by sin theta. Again, it is in compression as if we have considered for L0 E1. And at the same time, here now we have considered for L0 E1 span we are discussing for. So since the particular load is acting, at the position. So I will take at the point 6 over here. The unit load is considered at the L0, L6. This is L6, this is L5, and this is L6. So this unit load is now considering at this position. Before we have considered at this point, and now we are considering at this position. Since the unit load is acting at this position, L0, L6, and then the R1 value will be 0, because what we have the reaction forces for the members over here, it is like that. Since the unit load is at the support B, this is support A and this is support B, right? Since the reaction support no, load at the support B, then it will be uniformly varying to the A, and the value of A at A is 0. So since the value unit load is acting at A, then RB will be equal to 0, right? That is what the condition here. So A and this is B. So now the load is acting at L6. When the load is acting at L6, then R1 value will be 0. So that is the case, we have to substitute the value of R1 in the derived equation. So what we have derived is R1 by sin theta. So sin theta will be remain same, but R1 is 0. Then the total PL0 E1, the force in the PL0 E1 will be 0. So this is how we need to analyze for the top chord member of L0 E1. I hope it is clear for you now. Regarding this part, if you have any doubts, you can ask. And this part, this influence line diagram, that can be written over here. The negative sign convention you can have below the axis, and positive sign convention you can have above the axis. That is left to you. You can, but only thing is you have to denote the value of, or the sign, the minus or positive. The unit load, when the unit load is between L0 and L1, that can be shown the influence line diagram in this manner. So what we have derived 5 by 6 to the 1 by sin theta. So here up to this part, if you have any doubts, please let me know, else we can move for further. Yes. Shall I move forward? Dear students, let me know, shall I move forward, or you have any doubts in the discussion? Manjunath?
Yes, sir.
What shall I do? Shall I move forward?
Yes, sir.
Okay, one thing for everyone. ನಿಮ್ದು ಯಾರು ಹೆಸರು ತಗೊಂಡಾಗ ಅಷ್ಟೇ ನೀವು ರಿಪ್ಲೈ ಮಾಡ್ತೀರೇನ್ರಿ? ಐ ಆಮ್ ಆಸ್ಕಿಂಗ್ ಇನ್ ಜನರಲ್. ಎನಿ ಒನ್ ಕ್ಯಾನ್ ರಿಪ್ಲೈ. ಎದಕ್ಕೆ ಸುಮ್ ಕೊಡ್ತೀರಿ? If you have doubts, let me know, or else you can say, so no problem, you can go forward. ಅದನ್ನ ಅಷ್ಟು ಹೇಳಂಗಿಲ್ಲ ನೀವು? Okay. And when we are discussing for the top chord members, next we have this U1, U2. Now just we have completed for L0, U1. Next we have E1 U2. So that E1 U2 can be considered or can be solved, that I can refer with the diagram over here again. The same diagram that may be considered like this. The E1, okay, this is U1 U2. So now here we need to consider the U1 U2 force in the member. But here before going to that we need to have a section. For we need to consider a section of 1 1. uh, Again, if you have any other sections you can note for 2 and 3 like that. So here U1 and U2 is the member. In these members, in this member we need to calculate the force. So for this I am going to consider a section. This section shows it is a left side part and this is the right side part. So whenever the sign considerations, please listen carefully here. Whenever the sign considerations is done for the force in the member U1 U2 at the left side, that will be considered a negative. And when the U1 U2 force is considered on the right side, and that will be considered as positive, and remaining will be considered with the clockwise and anti-clockwise manner, right? So how it is exactly I will discuss here again. See, and this is a section. In this section I will consider the force for U1 U2. When the member is under analysis for the load is acting at the L2. When the load is acting at L2, so how, what would be the value of force over here? So or the span between L0 and L2 over here. The span between L0 and L2 when the load is acting in this span, in this span. So now taking moment about L2, that means I will just take the moment over here, that is before this I will just erase this. The when the load is at unit load is at in the span about the L2, if you consider the moment, so R2 is the distance over here, sorry, R2 is the reaction at the distance of 4, 4 times of here. This is 1, 2, 3 and 4. So R2 into 4, R2 into 4, which is having anti-clockwise movement. So I will consider the negative sign. And P U1 U2, P U1 U2, it is a member. In this member, which is considered on the left side of the section, now we are considering the negative sign multiplying with the height. So that means we are considering the moment at this point. So force into distance, distance is nothing but this is h, the force which is E1 U2 with the distance h, but at the section where you are considering on the left hand side, that will be considered negative, right? So if you consider at the negative sign, and then here see, if you after that it will be, the equation will be like this. But after we are simplifying this, we will be end up with P U1 U2 into h. This uh, R2 into 4a will be on the side of the taken to the right side, then negative sign will be plus over here. Just we are substituting the values of P U1 U2, 2 by 6 into 4a. 4a is similar, and what is the distance of for R2? But R2 is the value. R2 value we have, how we have calculated is, now the section is taken for L2 over here. Then R2 means we have to consider on the opposite side of the section. So opposite side we have 2 two spans, so R2 will be 2 by 6 like this. So for R1 will be 4 by 6, because you have 1 2 3 4. For R1 you need to consider in this section. For R2 we have to consider the opposite other side of the section where we have considered. So P E1 U2, which is equal to 2 by 6 into 4a by h. So once we can substitute and calculate, we'll be end up with uh, considering the sections over here. 2 1 z 2 3 z is, so 4a by 3h. 4a by 3h, which is having the positive sign, that will be considered for which is having negative sign, that will be considered as a compression. The negative sign will be compression and positive sign will be tension. So this is what the exact equation what we have considered for P U1 U2. And now at this point, the load may be considered on the spans. So if the load is in the span between like that, when the load is at a L2 and L6, and the load is considered in this span, then P U1 U2 into H and R1. So here R1 into, what is the reaction of R1 here? R1 is equal to 4 by A, sorry, 4 by 6. So it is a section over here. Since here we have 4 parts, 1, 2, 3 and 4 by 6 for R1. So R2 will be 2 by 6, this part. For R2 we need to consider these two, and for R1 we need to consider remaining on the other side of the section. So again, if you can substitute, it is nothing but here you can directly substitute 1 by 6, 2 by 6 instead of this value, and you can able to calculate the value of P E1 U2 as a 4A by 3H. So how we have calculated is, just we have substituted the value of R1 over here. So R1 is nothing but 4 by 6. So since 2 1 ja, so it is 2 2 ja, that's, and it is 3. So 2 2 4 4 by 3h. That is what we have calculated. So once the value of P1 U2 is 4a by 3h, when the unit load is acting at the position L2, at the position L2. So similarly, if it is at the L1, the similar case we can observe for reaction R1 and reaction R2. So if these reactions are considered on the equation what we have derived, then that will be considered for, that will be the value of inclined diagram at that point. So now P1 U2, P1 U2, since it is a negative compression which is compressing, so the value of 4a by h, that means the value of a, the value of a is the span of the each distance of each span and height of the section. If you substitute this, and you'll be able to calculate the value of the force in the member of U1 U2. And now this is 4a by h, and this is what we have calculated for U1 and U2. Again, if you have doubts regarding this, please let me know. Anyone, please let me know if you have regarding this part.
So once you load acting in L2,
What?
that's when load acting
Sorry, your voice is not clear. Please come once again.
acting on L2 sir, L0 L2 है ना.
L0 L2.
तो सब part explain.
You mean this part?
Yes sir.
Yes.
Yes sir. Yes.
Okay. See, uh, now we are considering for section 1.1. That means whatever you are asking, this part is considered on the left side of the section, and the load is acting on the left side of the section. So that means L0 to L2. That means that is the total span we are considering, but the load is acting on the this side, and the remaining part, and this remaining part is, this remaining part is considered for the load which is on the left side of the section. Just it is a difference between these two. Here the load is acting at L2. If the load is acting at L2, it is not like that the section is here, then the load is should be on this part. It is not like this. The section that may be considered, say for example, the beam having the beam, and at section, at this section we will be having a left and we will be having a right. So that in that manner it is considered. When the load is acting at L2, just we are taking the moment about this point. It is not like that it is only at L2, it is not on, it is at L1, it is not at L0. Just we are taking the moment at L2 with reference to the reactions and the force U1, U2. So just what here it is written, R1, sorry, this R2 will be the reaction force for the distance of this one. So what is the distance? 1, 2, 3 and 4. 4 numbers of A is there, that is 4A, right? R2 into 4A, which is moving, which is having anti-clockwise movement for this L2, correct? So this is having L2, sorry, anti-clockwise, R2 into 4A, which is negative again here. And now the U1 U2 is a force. U1 U2 is a force like this, at this point, at the point where we have like this. So U1 U2 will be considered on the left side of the section with a negative sign, with a height of h, with the height of this h. So this is the height. So U1 U2 is the force with the height h, then force into distance to the L2 over here again. So this is what it is written. After this we are just simplifying. Just observe, this is what written extra over here. Just the observation is done for this. So R2 value is nothing but 2 by 6. How it is written? So R2, for this R2 we need to consider the remaining part of the section on other side. So here we have two parts for L2. So R1, so sorry, this R2 will be 2 by the total span 6. That means the R2 will be having the force reactions of 2 by 6 of the total force on the span. So R2 will be the remaining 1 and 2 parts for 6 total 6 spans. It is not a length or a number, it is a number of span having two numbers of span with the equal distances are here. If it is not equal distance, then you can directly consider how much part. If it is a 3 and if it is a 5, that will be 5 by 3 meter. So 3 by 5 meter, right? That is the ratio of the R2. But here we have 2 times of A and remaining 4 times 6 of total span for the total span. So that is what the value is substituted over here. So just P U1 U2 it is written, and R2 for A will be taken to this side, which will be like this 4 to A, that is R2 by 4A. So P U1 U2, which is H is considered at the bottom. Right, just it is simplified, the equation is simplified, then we have written to 4a by 3h. That means we are substituting the value of R2, we are substituting the value of R2, then we are able to calculate is 4a by 3h.
Thank you.
Okay. Okay, now this is about the portion U1 and U2, and similarly we need to calculate the U2 U3, right? And that is another section we have considered at the point. So how we are considering at that point, that I will show here. Okay. So U2, U3 is a part again. So what we have calculated here in the previous slide, previous part, here it is 4a by 3h. 4a by 3h. That means we are referring this simplification or considerations for the U2 and U3 also. So how we have considered, just the moment at L3 is considered and the load as L3 is also considered. So that again here it is on the section at the center, since left side and right side will be similar over here, but here what we have considered two, that is case 1 and case B, case A and B. Case A we have considered on the left side and case B we have considered on the right side. So L2, L6, L0, L0, L2. So that is the case. Now here the same case, the same thing if you return for L3, when the load is at L3, just observe this equation. So R2, sorry, P U2 U3 will be the equation. So when the load is at L3, taking moment, here we can express. So when the load is at L3 at this point, when the load is at L3 at this point, then the whatever the load is acting at this point, that may be considered with the moment at L3. So moment at L3 will be again R2. R2 is at the point for 1, 2 and 3 span. So 3 by H, just we are substituting R2 is equal to 3 by 6, right? 1, 2, 3. 1, 2, 3. So that means R2 is on the other side of the section, that is there are 3 parts, 3 by 6 is the, and that will be 1 by 2. Just we are substituting 1 by 2 in the place of R2 over in the previous expression. So here in this part, instead of 1 2 by 6 we are just substituting 1 by 2, then that will be the equation 3a by 2h. And that means a similar case we are solving, that is why we are just substituting the value of R2. Then 3a by h will be 4a by h is considered because the load is acting at the point L2, but here the load is acting at L3, then only we have 3 members over here, so that is 3a by h. This is how the reactions are considered, and the force in the member of U2 and U3 is 3a by h, and that can be considered with reference to this diagram. Since it is an compression member, so we'll be having the apex point as 3a by 2h for L0, L3 and L6 spans. This is for this is completed for the top chord members. And at the same time, if we have different kinds of span distances, then you could be substitute the values of the respective span over here. That also I will discuss with them, taking the problem with the numericals, numerical values for height, angle, load, as well as span. So whatever it is, the point we are discussing is, it is for the way we are going to analyze for the member, we are going to consider for the forces for the member, and after that we need to calculate for bottom chord members also. So influence line diagram for bottom chord members, what are the bottom chord members over here again? L0, L1, L1, L2 and L2, L3, and these are the bottom chord members. For these bottom chord members we need to have the simplification. It is just simple that what we have considered for L0 U1, the same thing that need to be considered for L0 L1. So for this L0 L1, before that I will just consider the So this L0 L1 that we need to have consider. So for this, if you consider summation of vertical forces, so vertical forces will be L0 U1, which is resolved in vertically. What we will get sin theta, P L0 U1 sin theta, and apart from that reaction R1. So that will be P L0 U1 R1 sin theta. Right? This is already we have considered. And for L0 L1, if you consider the horizontal force, so if L0 L1, if you consider horizontal force, then this force will be resolved to this direction, that is L0 U1 cos theta, P L0 U1 cos theta, because which is resolved to the horizontal. Here we have resolved to vertical, and that is PL0 U1 sin theta. And here we are resolving for horizontal, because we are now calculating for L0 L1. So L0 L1 will be having the force of horizontal PL0 U1 cos theta, right? So again, section is considered, and sign convention PL0 L1. Just we are substituting the value of PL0 U1. So what is P L naught U1? Minus R1 sin theta. Again, this cos theta is similar over here. That means P L naught U1 is minus R1 sin theta, and cos theta is written same. And then this will be considered, since it is at the left section, minus sign, and minus this minus sign and this minus sign will be get cancelled, and the tension member, that is total positive sign will be having the total tension member will be the main. That means at the bottom card we will be having the tension, and at the top cards we will be having the compressions. This is what the calculation is done for L0 L1. L0 L1. Just we are taking the horizontal force in the L0 L1, because since it is an inclined, we need to resolve this force for horizontal as well as vertical. Since it is an inclined member, we need to resolve that force to vertical, right, and for horizontal. So if you consider for horizontal and vertical, for this PL0 U1, if you resolve for this, it is a theta, hence it will be L0 U1 cos theta, right? And at this point, if you consider, this will be L0 U1 sin theta. That is what it is considered in the equation. It is sin theta. So substituting the value of PL0 U1 PL0 U1 as a r sin theta, that will be the equation. Right. This is about the bottom chord member of L0 L1. Right. Is that clear, dear students? Again, one more thing, I will share these notes in your class after completion of all members. Just go through that. And again, this video will be available in your classroom as well as YouTube channel. I think all of you have got a YouTube channel link, and I have shared with your friends. Please connect with your class representatives, and you can access these videos, class videos, any time when you are free, and you can able to listen that things, and then you are able to get the doubts, and then you can discuss with me. Right? This is how the L0 and the L1, that is bottom chord member, we have derived, and at the same time we need to derive for the other members L1, L2, L3, right? This is the another members that I will discuss in the coming classes. uh, if you have any doubts regarding this discussion today what we had, you can ask, else you can ask me later through WhatsApp itself. Okay, the remaining part will be having this much, that is the part of bottom chord members. And Arun and Vinay,
Yes, sir.
is there any lab in the today afternoon?
Today, sir. Yes, sir. Geology we have.
Wednesday.
Yes, sir.
Okay. Just I was planning to take an extra class in the noon. Since I don't know how many of you people are understanding and not understanding, you are not able to express it. That is why I plan to take an extra class for this. It's okay. Tomorrow I will plan for it.
No, sir. If no lab, I'll let you know, sir.
That is what I am asking. If there is no lab, then let me know. Then I will schedule the class for an hour. Then we can go for it. So in
Shall I?
class, it is a good thing. Yes.
Shall we begin, sir?
Once, yes. I will conclude this class today, and in coming class, please try to watch the video what we have discussed today. Okay, with this regards, with this note, I will conclude this class. Thank you, everyone.
Thank you, sir.